Want to transcribe audio like a pro? Here's how to use Java and leverage OpenAI's Whisper API to do both transcription and analysis of audio files. Welcome to Tales from the Jar Side. Now what you see here is a tutorial on the OpenAI website. This is platform.openai.com, the developer site, and they have a section here called tutorials, and one of those is creating an automated meeting minutes generator with Whisper and GPT-4. So the idea is they start off by telling you go register and get an OpenAI API key, and they use Python, and they're going to go ahead and transcribe the file and then write out the transcription as a, believe it or not, Word document. Yeah, that part I'm not going to do. And then it starts off with a problem, believe it or not. And the problem is they say the first step in transcribing the audio from a meeting is to pass the audio file to our API. And it will automatically transcribe it for you, except we have a problem, and it's that the audio file that they supply in this download sample audio file is too big. Now, what do I mean by that? If you take a look in their guides on speech to text, how do you turn audio into text, then they either handle transcriptions or translations, but translations are from other languages into English only. Yeah, I'm not going to deal with that. Transcriptions and translations both use their Whisper AI model, and that's a link to more detail about that. So transcribe audio into whatever language the audio's in. But here's the problem. File uploads are currently limited to 25 megabytes. And for audio files, that's still not very long. I mean, it's only a couple of minutes. I don't know about you, but I haven't been to too many meetings that lasted a couple of minutes. That would be nice. Okay, now in other videos in this series, I start off by saying, well, there's a REST API involved here. And that's what they're showing in the quick start, that they provide a curl request and then they process the results. And normally with the REST API, like the ChatGPT itself, there's JSON data, both being transmitted as part of a post request like this and returned as part of the response. But this is different from that. This is way simpler in some ways. And the idea is in the post request, you are sending in your authentication header and the content type header as form data, but you're providing the binary file as part of the form, and you specify the model. So this is interesting because, first of all, there's no JSON data being transmitted. And in fact, the JSON data you get back looks like this. This is the default. You get a JSON object with text, and it has the string in it. But as it turns out, you can change the default so the response you get back is just pure text, and they don't have to worry about JSON data at all. So it's kind of nice, but there's a complication here, and the complication is I have to send both binary data and text data in the same HTTP request. Java's HTTP client, which is the API I used on earlier videos in this series, doesn't really know how to do that, isn't good at that. But the Apache HTTP client does know how to do that. So let's take a look at that. Now, if you want to add extra parameters, one of which can be response format, and when you set text there, that's exactly what I want, because then I'll just get back everything as text. If you look at the actual API docs for creating a transcription, here's a sample. See, they're putting in the headers and the file and the model, and they get back this response. Again, I'm going to simplify this, but I'm going to use response format as a way of saying I want text back, not the default, which is JSON data. But that's the only real change I'm going to make. Let's take a look at the code now. Now, this is my class called Whisper AI, and this is part of my GitHub repository. There's a link in the description. There's the base URL that I'm sending my message to. Now, again, the big challenge here is that the size of the recording has to be 25 megs or smaller. And if my file is less than 25 megs, that's fine. I'll go ahead and transcribe it. But if it's larger than that, I need to break it into chunks, and I'll get into that in the next section. So here I'm going to say my max size on each chunk is only 20 megs, just so I'm guaranteed there's no way I accidentally exceed that 25 meg limit. It's really annoying to come close and then have a round off error exceed it and the whole thing shuts down. Here's the OpenAI API key, which I save as an environment variable, and there's my model. Now we'll come back to this prompt in a bit. So here is the usage of the Apache HTTP client library to transmit the request and get back the response. So I'm supplying a prompt, which I'll discuss later, and the file itself that I want to transcribe. So in the Apache HTTP client API, there's an HTTP clients class that has a factory method to create a closable HTTP client. So I get the default. The fact this is closable means I can use it as the argument of a try with resources block, and when the try block is done, then it will get closed automatically. Now they have in their API a special class for each of the HTTP verbs. So if I want to do a post request, I use HTTP post. If I want to do a get, there's HTTP get, and so on. So I create that at the URL we want to access, and I set the header for authorization with my key. This is all normal stuff. This is where things become interesting. In order to transmit the post, I'm going to put in what they call an HTTP entity. In this case, it's a multi-part entity builder because I'm doing form data. So I set the content type to multi-part form data, and here is the file body in binary for the actual chunk. Now again, if the file size was less than 25 megs, that's the whole file. Otherwise, I'm going to have to break it up. Here I specify the model as a string body, so that's text. I specify the response format as text, the language as English, and then again the prompt we're going to come back to, and build it up and put all that in the HTTP post. So far so good. Then you use the execute method to transmit the post, and the docs for that say that takes the classic HTTP request as opposed to something asynchronous, and an HTTP client response handler. Now if I look at that, that's an interface with a single abstract method in it, so I'm able to encapsulate the process of generating a response object in a Lambda. So there's the response. I'm going to wrap it in another class that they provide called a status line, so I could print out what the status was to make sure everything was okay. And then I'll get the entity, the body out of it, and just return it as a string, and that's the whole thing. So there really isn't that much to it. Once you figure out how to set up the request, I just transmit the request and I get back a string, and the rest is exception handling. Now, if the body, again, if the file was only 25 megs in size, we're done. But that doesn't happen very often. Didn't even happen in their own tutorial. So let's go see what to do if the file size is too big. What I have here now is the real method I want to call, transcribe. Now, transcribe says, give me the file name, and it wraps a file around it. And what I'm going to do is break the file into chunks, make a transcription of each chunk, fill in that list, then I'll just join all the transcriptions together and write it to a file. If the file length is less than that max allowed size, then yeah, we just call the method we just went through and everything's fine. But if it's bigger than that, I made this class called a wave file splitter. Now I'm dealing with wave files because in their tutorial, the downloaded file was a wave file. Now this code has nothing to do with AI. This is way more than I ever wanted to know about java.sound.sampled package, which has been around in Java for decades and I've just never used it. Let me just give you the basics and then we'll go on. So I'm going to make my list of file that I'm going to populate with the individual chunks, and I have a counter because the plan is that each file will have a -1, -2, -3, some dash counter in the file name itself. So if the source file can't be found, yeah, we have an exception, right? But now I get the audio input stream on that source file, which returns an audio input stream. And this is something, since it's an input stream, it can be put in the try with resources block. So again, it's going to get automatically closed when the try block ends. I get the frame length and the file format out of it and the format itself. And the frame length and the frame size is how we're going to determine how much of the file to process. See, I know my max size that I want in terms of bytes. I'm going to divide by the frame size, and that's how many frames will be in each chunk, so that I divide at a frame boundary. I make a byte array to hold that chunk, and then while the total frames is greater than 0, I either am going for the whole frames per chunk section or whatever total frames are left. Read into the byte buffer from 0 to that size, and then if the bytes read is greater than 0, that's reading the original buffer. Then I'll go in and well, first of all, actually, this is the chunk file with replacing .wave with the -123.wave. But here we get an audio input stream, do a byte array input stream, reading into this file with the format, with the frames, and write them out as a wave file. Add them to the total chunks and increment the counter, and then decrement the number of frames. And that's it. Now, it looks a little involved. It's not too bad. I did use AI assistants to help me write this, but it works. And to demonstrate that it works, let me go to the test class here. So my test class has a small wave file, which is only 4.2 megs. I made this from one of my YouTube shorts using FFmpeg just to extract it. And then here's the one, the earnings call that was given as part of that tutorial. Make the splitter, and you can see if I split the small file, so I'm just going to wrap a file around it, print out the length, split it into chunks, and say it should only have one chunk in it. And when I run that, you'll see, yes, that passed, and the file size was, significantly less, 4.3 megs. Than my limit. This is the more interesting one. I'll take the overall tutorial file. I'll print out its length. I'll assert that it's greater than the max, or why are we doing this? And then here, I'm going to split it into chunks and make sure each chunk is smaller than the max allowed size. I'll print out how many there are. And then this little block here sums up the individual chunk sizes. Make them into a stream, map them to longs, and add them up. And I'm going to compare that to the wave file length in the source. So I'm using assert j's, assert that, and is close to within percentage. So let me run that one. And what you'll see here is that the source file comes out like about over 50 megabytes itself, but it's 48 megs. It's just 58 million bytes. It's a binary thing. We got 3 chunks there, one of size 20, another of size 20, and one of size 8, because the overall total is about 48 megs. And in fact, if you look on my file system, you will see that this created earnings call -1, -2, -3, and also the assert j exceptions -1. Let me get rid of all those files. I don't need them for the rest. Okay, so the file splitter seems to be doing its job. And then back here in the API, I'm going to retrieve the split chunks. So I've got all the chunks from there, and I'm going to go through each chunk and do a transcribe using the mechanism I showed before. And now it's time to talk about that prompt. Now, if you go back to the API, they say the prompt is a string that's optional. An optional text to guide the model's style or continue a previous audio segment. The prompt should match the audio language. Yeah, okay. Well, in the original guide, if you scroll down a bit, they talk about longer inputs and how they have to be split up, but then they bring up this prompting section. You can use a prompt to improve the quality of the transcripts generated by the Whisper API. The model will try to match the style of the prompt, so it'll be more likely to use capitalization and punctuation if the prompt does too. Now, what you can do, and they get into the details here, is they say, first of all, you could put in as your prompt commonly misspelled words, or rather you put in the correct spelling so it knows what to do with those words, and that's very useful. But then it says to preserve the content of a file that was split into segments, for each segment supply a prompt being the transcription of the previous segment. Every time I get a response out, I use that as the prompt for the next segment. So over here you see I start off my prompt with this word list, and the word list at the top are a bunch of words that are likely to be misspelled because they're technical or they don't know them at all, and even things like GPT-3 and Dolly, and of course my last name, which nobody will spell right. So in the first chunk here, I start with the word list. And that's what's happening here. And then that'll give me a transcription, which I'll add to the collection, and then set the prompt to that transcription, and round we go. And that processes them all. And of course, each time I'm done with a chunk, I can now delete it. There's no reason to keep it around. So this little loop here is the one that takes care of transcribing the whole file. And that's all there is to it. Now, finally, when I'm done with the transcription, I'm going to join that list, into a file with space separated in between the individual chunks. I'll find the name of the file and transform.wave into .text, and I'll write it all out. I got a little private method to write it out, and I'm finished. So let's take a look at a test of that as well. So I have my short file and my longer file. So for my short file, I'll call transcribe, and I'll get back a transcription that isn't blank, and it has the word assert J in it, and has a line count of only 1 because it all fits. So when I run that, it doesn't take terribly long, but it should give me back that it transcribed the file. There's that status 200, make sure it worked. And now I've got assert J exceptions.txt inside there. And if you want to see it, here's what it looks like. And you can see it's one long line. I've just got word wrap on in that section. Now for the second test, I want to operate on a file that's bigger than that. This is that earnings call wave file that they supply in the tutorial. So I'm going to transcribe that and assert again, it's not blank. There's the name of the company that comes in there. And it has a line count of 3 because, again, it's 48 megs. That's 2 20 meg chunks and an 8 meg left over. So let me run that one now. And there you have it. You see that each one of these files was transcribed. They all got 200 OKs. And here is my output right here. And you can see that it's 3 lines long because that was a different line for each individual transcription. And there's the name of the company, and there's the balance sheet and all of that. And the transcription's working just fine. Now let's take a look at the actual tutorial, the part that they went through. In the tutorial, after they transcribed the audio, then they said, let's summarize and analyze the transcript with GPT-4. So the rest of this is GPT-4. Now I have a separate video on doing analysis with chat messages and requests and responses and all of that. But let's go ahead and see what they did here. They said, all right, their meeting minutes method is going to take that transcription and come up with a summary, extract the key points, extract the action items, and do something called a sentiment analysis to find out if it's positive or negative or whatever. And they're returning what is effectively in Java a map with the keys and the values of all of those results. And if you look down at the individual sections, they're all chat completions going to GPT-4 where the messages are either in a system role for the complicated prompt or a user role which has the transcription, and then they extract the result out of it. And 1, 2, all of these, all 4 of them are the same except for the content, what they're asking it to do. You are a proficient AI with specialty in distilling information into key points, blah, blah, blah. There's the action item one, there's the sentiment analysis one. Let's take a look at how I did it. All right, now, there's my Whisper AI. There's the chat GPT, and my file is under source main resources, and the text file is going to be in a text directory underneath that. I extracted all of those chat requests into their own strings. So here are the prompts. You're a highly skilled AI trained in language comprehension and summarization. I'd like you to read the following text and summarize it in an abstract paragraph. Or based on the following text, identify and list the main points. Or please review the text and identify any tasks, assignments, or actions that were agreed upon. Or your task is to analyze the sentiment of the following text, consider the overall tone of the discussion, the emotion conveyed by the language used, and the context in which the words or phrases were used, indicate whether the sentiment is generally positive, negative, or neutral, and provide brief explanations for your analysis where possible. Okay, got the idea. So here's what I'm going to do. Now, this looks way more complicated than it is. This basically says, tell me what file to transcribe. I'll go look for it. If it already exists, I'll just read it in. So that's a one-liner, except that it has to go into a try-catch block. Fine, I'll read it in. If it doesn't exist, I'll transcribe it. There, all done. So it looks complicated, but it's an if statement with a pair of one-liners in it. This is the processing I want to do. I take all 4 of those prompts and I put them in a list. And then what the heck? Let's process them in parallel. I mean, why not, right? They're all just post-processing of the same transcript, and none of them have anything to do with each other. So I can do this in parallel. It's stateless. So I'm going to write out, I'm going to use the peek method in Java to say which thread I'm on, just to indicate that we are in fact operating in parallel. I'm going to need that in a minute. Now, the way the ChatGPT API works is you create a request, and I have to show you this method called getResponseToMessages. This is a method that says what model are we using and takes a var-arg list of message objects, and a message object is a record with role and content. So what I'm doing is saying, let's get that list of messages, and I'm going to make a chat request with the model I want and the list of messages and a temperature. I'm going to create a chat request from that and then get the response, or actually create the response from the request. This again is another record with the nested records and all the information in it. And you can see I just walk my way down. .choices, .get of 0, .message, .content, and that gives me the same response that they had in their Python script. So with that in mind, back into the tutorial, I'll say, okay, for each one of these prompts, I'll specify the model's GPT-4. I'll have a message which is in the system role, which is that prompt that they gave us, and then a message in the user role, which has the transcription that was generated by the Whisper API, and I'm just going to print it out. I'm not writing it to a file or anything. And that's the whole thing. So keep your fingers crossed. Let's see if this works. Okay, so there's good news and there's kind of not as good news. It's not really bad news, but it's not great. First of all, you see that I am in fact running on 4 separate worker threads, the main thread and 3 workers. That's fine. We are in parallel. And I'm writing out the response as a JSON object just so I can see it. See, there's my chat completion, there's the model, and here's the output. So this first one says there's no specific tasks, assignments, or actions to be done. And great. So there's the print of that. And then here is the one that's also completion that says the sentiment is generally positive. And we write all that out. You could take a look at that if you're interested. And then this one says, okay, in the Q2 2023 earnings call, FinTech Plus Sync's CEO John Doe reported a successful whatever. That's the summary. And then in the last one, the bulleted list of key points that were made in the description. The not so good news is that if I hadn't cut out the time, you would have seen that even though I'm clearly running in parallel, I have a feeling that they are throttling them. They're making them sequential on the server side, because I'm making the calls in parallel, but they're coming out one at a time, and I don't know if I'm saving any time against what I would have saved before. So I'll have to look into that a little bit more. But that's it. Everything worked. Everything came out okay. And now you know everything about how to use the Whisper AI with Java. No records needed really, unless you want to do this ChatGPT analysis. But the transcription part, that's pretty straightforward and it works pretty well. All you have to do is use the code that I'm providing in order to split up your WAV file into different sizes, different chunks, so that they'll all work together and update the prompts appropriately as they go. There will now be little boxes and everything showing you other videos in this series. I hope you find them interesting. So thank you very much for your attention and good luck from Tales from the Jar side.
Hey there, it's time to tune in to Tales from the Jar, so let's begin. Java, coming in spring, oh my. Groovy graphic, don't be shy. Tales from the Jar side, oh yeah. Crack open the code, let's take a ride. From design patterns to the latest trends, your weekly tech toast that never ends.